Very good morning to you, grade 12s. Welcome to our lesson for today. Before I start, I want to remind you always that our lessons kindly brought to us by VT Africa with its subsidiary companies, Bible Tech and Astra Tech. Our lessons are kept aligned. Sure you know that. Kept aligned, brought to us by VT Africa and Astra Tech. Today, we'll be continuing with the acid and bases. I might not ask you to log on. We'll do the revision quickly together. All right. The previous lesson, you started your topic on acids, bases, on acids and bases. Let me say acids and bases. However, we would also talk about neutrals. Who remembers what you defined bases from your previous lesson? An acid is a type of a chemical that forms solutions that taste sour due to high concentration of positive hydrogen ions. My grade 7, it's a good introduction into the science of it. And the acid, it's a type of a chemical to distinguish from a base. Test. It tastes sour due to high concentration of hydrogen ions. It's very important to note hydrogen ion, and their charge is positive. Positive hydrogen ions. Did we write the sign for hydrogen ions? It's just for us to know. We would meet this as we move on to grade 9 and 10 when we start to specialize in grade 10. But the hydrogen ions are written like this. It's an N with a positive charge, which means they are positive. That gives us an acid. What did we describe the base as? It's a chemical that forms solutions that taste bitter due to low concentration. The taste now is bitter due to low concentration of positive hydrogen ions. Acids will react with bases to form salts. As an example, neutralization. You remember, we'll move on to your pH scale, is when an acid and a base react and create a product that is neutral. When an acid and a base react to form a product that is neutral. When they react, they form neutral. Please, my good servants, this is something that we meet in our everyday lives. I wouldn't want my clever learners to ask me what is acidity or what is alkalinity. And they look very surprised when we start to talk about when they get to grade 10. This forms a very good basis. An acid, sour taste, high positive hydrogen ions. Bitter taste, low positive hydrogen ions. Neutral from the term itself. So if I were to ask you about the charge, then positive ions, low positivity, neutral means there's no charge. It's a very good introduction. Let's move on. Properties of acids, bases, and neutral. Acids are corrosive, acidic. Would look at the chemical formula, how we use it in everyday relating to the immune system as part of examples. Now, this is very important. Very important. This is what we call a pH scale. A pH scale helps us to be able to measure whether this substance is acid or is a base. A pH scale measured how acid or basic a substance is. Sorry if I use the term alkaline, forgive me, I'll still be referring to the basic nature. But let's strict ourselves to how acidic or how basic a substance is. Good. So we use what we call a pH scale. My wife was asking me, what is a pH scale? And she graduated last year with her honors degree. She did fine arts, and she was asking me what is a pH scale. Then I said, okay, no, what is the pH scale when I'm teaching my grade 7s currently in natural sciences, acids and bases. So even if you divert in your career, you do fine arts, you do everything, at least when we talk about pH, we should talk the same language. Good. So that's our pH scale. It measures acidic and basic. We should try and make a demarcating line here from 0. So a pH scale is a graduation or a measurement from 0 to 14. Maybe you can't see clearly from mine. From 0 to 14, 7 being the mid. So this side becomes the acidic side. From 0 to 7 to 6, so to say. Above 7, basic. Fine. So it means if a substance has got a pH scale of 1, it's strongly acidic. Gets less acidic as we move from 1 to 2, 3, 4, 5. Urine, as an example. Water should be neutral with a charge of, so the pH scale ranges from 0 to 14, 7 being neutral. Right. pH of less than 7 is acidic, greater than 7 is basic, or what I term alkaline. So here are good examples of our acidic substances. Gastric acid. Where do we find gastric acid? Example, in our stomach. Your lemon juice, orange juice, tomato juice, black coffee, less acid. And I've got a good color shading. So you know, you'd find out when you get to our grade 10, 11, and 12, we use some kind of paper that when we dip it into a solution, for example, lemon juice, it would give you this red, light red color to show how acidic it is. If you dip it, if it turns yellow, it shows you it's moderately acid. So these colors will give us the acid composition of whatever substance that we are covering. So that's a very good pH scale. But for now, it's grade 12. See, red gets into yellow, green, neutral, there between green and blue, which means it has no charge. The moment we get to bluish, your distilled water, seawater, baking soda, milk of magnesium, ammonia solution, soapy water, basic. So let's remember these colors. Thank you. Still, the pH scale is there with your diagrams of the same items that we're mentioning. Your bleaches, I'm sure. Where does my sanitizer fall under? It has got alcohol. 70% alcohol. Where does it fit? You should have got our milk. It's supposed to be 6. Eggs, they're becoming basic. Soap, bleach. So you should tell tomatoes, bananas. There's my scale. Of course, we are doing a quick revision. Acids such as lemon and other fruits have the following properties. They taste sour, they feel rough on the skin. Many are dangerous to taste and feel because corrosive. So those are properties of acids. I once read a small article from Joburg there. I was waiting for a taxi sometime back in 2009 by Orlando Plaza. I'm sure some of you know it. I picked a small article, a small paper. It was denouncing Coca-Cola and Pepsi. It was saying, I don't put those acids into my stomach. That was the person who wrote it. He said, rather, I would use them to clean my bathroom sinks. I would use them to clean my toilet seats and so forth. Maybe it's because of the acidic nature of them, right? So these are some of the everyday examples that we use. Your vinegar, your peps, your orange fruits, your lemon fruits, they taste sour. They might feel rough on the skin, and they are dangerous to taste. Some of them, they can be very corrosive. Wonderful. Bases on the other side, the carbonate of soda, washing powder, bleaches, and most household cleaners. They also have a bitter taste, slippery on the skin, dangerous to feel due to their corrosiveness. Soluble bases are called alkali. So if they do dissolve in water, we call them alkali. Not much worried about the terminology, but let's know their properties and everyday examples. I will find them. Thank you. Substances that you cannot classify as either bases or acids. They shouldn't be dangerous by nature, so they are not on the other side of the pH scale, on the 7 going downwards or on 7 going upwards. They're in between there. They're around the 7 mark. They are neutral. They are not dangerous. Example, water. That's why you see when you go into the next grade, when you're doing your experiments, whenever there's a problem with acidic, we clean with lots of water because it is neutral. You're cooking oil, and when we add salt to the food. So substances that are neither bases nor acid can be made by reacting bases and acids. We can get to a neutral, right? Neutrals have no effect on the litmus paper. They are harmless. The litmus paper is the one that is one substance is one paper that we use to measure acidity. It's like a small thin piece of paper. If you put it there, it gives you this color depending on the type. That's your litmus paper. Okay, great. 7s, hope we are together. Let's move on to the next slide. All right. So we have said, I hope I'm not too fast for you. On neutrals, example, cooking oil, your glucose solution, your salt, and your pure water are examples of products that when you measure the pH, they should read around the 7 mark, as I've shown you. Who remembers listening to the test of a cold drink? Or you don't like listen to it because no, oh, this is Coke, it tastes like this. This is Fanta, it tastes like this. So I would want you to test to try and pick the sour or the bitter taste. That is different liquids that you're going to drink. For you to be able to give me more examples of acids and bases. Right. Having said though, I want us to move on to the next activity. So I want us to do this activity together and to test whether we've understood our acids, our bases, and some neutrals, grade 7. Right, here's my first question. I want you to tell me whether it is true or false. We can sense 3 types of tests with our tongue. Can we sense 3 types of tests with our tongue? Give you a few moments to think about the answer. The answer says false. We can sense 4 tests with our tongue. A salty test, a sweet test, a sour test, and a bitter test. Let's move on to the next question. Very simple. Acids taste sour. Acids taste sour. We have just talked about the 4 tests: sweet, salty, sour, and bitter. So where do our acids fall? Acids taste sour. Are we getting them right? And then I would challenge you to give me an example of any acid sour testing Example, we can give many examples. Sour test. Your Amas. Amas is a sour testing milk. That's one. Sour test. Lemon juice is sour. Tomatoes themselves. It is sour. See, it reminds me of last week. I had a problem with my upper stomach, complaining of pains. Then the doctor told me that you have got a condition of gastric ulcer, so you mustn't eat or drink fizzy drinks, acid food, including tomatoes. How I like to put tomatoes in my food, so much. So tomatoes, they also taste sour, they're acidic. All right. Next, if we want to know if something is acidic, if something is acidic, we can test it. False. Not all acids are safe to test, such as laboratory. So the question is plain. If we want to know that something is acid, can we test it? The answer is no. Why? Because not all acid-containing substances are safe to be put in our mouth. Some are not. So we can't test everything. Example, laboratory acids, we can't test them. All acids are dangerous. All acids are dangerous. You can think of that grade 7s from the example that I've just given you. Just see the range of acids from something that we eat to something that is very poisonous. So should we say all acids are dangerous? It cannot be correct. There are many household acids which are not dangerous. Acetic acids or even foods in our acids. I just give you an example. Tomatoes, lemon juice that we even put in our milk. The one that I've just drank before I came to work. I prefer lemon juice. I like the sour taste. Number 5, vinegar is a mixture of a small amount of acetic acid dissolved in water. Vinegar is a mixture of a small amount of acetic acid that is dissolved in water. It is true. Vinegar is made up of a mixture of the two. Question 6. As laboratory acids must be handled with care and using protective clothing. We should handle them with care due to their corrosiveness, and we should always be in our protective clothing. That's where you see guys who are coming in and out of the lab, they'll be wearing their laboratory coats. The following symbol means you can wash your hands using this substance. There's the symbol. It says the following symbol means you can wash your hands using this substance. Can you? It's false. This symbol means that that's a corrosive substance. Can you see the corrosive? Where it's dropping, it's even eating up. If something is corrosive, it eats up matter. You have done your properties of matter before. So it's corrosive. Look at this doing to your hands. So it's a dangerous substance. Formic acid is commonly referred to as vitamin C. Formic acid is referred to as vitamin C. True or false? It's false. Formic acid is not vitamin C. Rather, ascorbic acid is commonly referred to as vitamin C. If I may ask you, which type of food substance do we get our vitamin C? Most of your citric acid. Which ones? Sorry, citrus fruits. Which ones are examples of citrus fruits? Grade 7, your oranges, your naches. And this time they are ready there in market. Borrow 2 rand, buy 1, and you get ascorbic acid, not your formic acid. Right. Our last question is, oranges are the food which contain the highest amount of ascorbic acid. I have just told you the answer. False. There are many other fruits with higher ascorbic substances, which such as strawberries and cherries. However, the term highest is what dismisses our answer. Oranges, they are good, and they are more readily available than chilies and strawberries, even in terms of cost. So it's better I eat my higher amounts of oranges if I can afford them. If you're fortunate enough to get strawberries, perfect. But chilies, they can be too hot for your liking. All right. You'd find out that some of the things that we've mentioned, we covered in our revision, they're opening us for the next lesson. Would also talk about more of them, more of the everyday substances that we use, and we look at their scientific names. Grade 7, we are getting there. If I say ascorbic acid, if I say formic acids, you should be having some idea. Why? Because you can be able to read. You are able to read what are some of the labels that you find on the containers of food substances. You see, sometimes they talk about allergies. I'm allergic to this, I'm allergic to this. So for you to be able to know that, you should read the composition of the food items that you'll be taking. So it's very important to relate the very nice content we are covering with our everyday life. So to wrap up, acid, bases, alkali, types of foods or examples. The litmus paper gives us, by use of color, the type of substance that the food falls under. Is it an acid food or substance, or is it a basic one? So next time, I'll organize another practical for you where we should use our litmus paper dip it, and I'll just show the color. You should tell me roughly, is it an acid or it's a base? Or if you can tell, maybe even with the number, the rough reading. Is it 5? Is it 6? And is it in between? It can be 4.4, can be 5.5. It doesn't necessarily mean that it has to fall under either 7 or under either 10. It can be in between. Thank you very much, grade 7s. Enjoy your day. The strike was not good today. It meant some traveling was difficult for some of our teachers, and we need to stand in. I hope you enjoyed our lesson. Let's meet again, same time tomorrow. Ciao.